These notes are going to teach you how to deal with problems that have 0 as an exponent or negative exponents. Up until now, all of the exponent rules that we've done have been positive exponents. So these are 2 additional properties in addition to the 3 that we've already done. And you will have to make sure that you are on top of all of them and that you understand each one of them and can apply all of them in a combined way in a problem. So the first thing we're going to talk about is the power of 0 rule. And what this rule says is that a non-zero number, which means any number other than 0, but a non-zero number raised to the 0 power will always be 1. Okay, it will be nothing else unless there's other stuff in the problem. So what I'm going to show you are a few examples and show you just how this works. Right? Don't worry so much about the why it is the way it is right now. I will come to that in another lesson. But for right now, just understand that anything raised to the 0 power will be the number 1. Right? So in this first example, if I give you in parentheses negative 3x to the 4th y in parentheses, all raised to the 0 power. Because everything in the parentheses is raised to the power of 0, this answer will be 1 and nothing else. Okay. If I give you just a random number of 43 to the 0 power, you can even check this in your calculator. It will also tell you that anything to the 0 power is the number 1. Okay. If I give you just variables, y to the 0 power, that is going to be 1. Okay. The uglier the problem is, it doesn't matter. So don't be panicky or scared away from the ugliest problems. I could take and give you, let me number these while I'm looking at it. Okay, I can give you this problem as ugly as it's going to look and as nasty of stuff as it's got in it. And you don't have to know anything else about any of the numbers other than the fact that as soon as all of that inside the parentheses is raised to the 0 power, the answer is 1. Okay. The only time the answer is not going to be 1 is when something like the following example occurs. Okay. If I give you 5 times x to the 0 power, the only thing that has the power of 0 is the x to the 0 power. So this is really separated as 5 times x to the 0. X to the 0 turns into 1 based on the property, but it still has a times 5 out there. So in this case, the answer will be 5, but only because there were other things attached to the number or letter that had a power of 0. Okay, so just be aware of that. If everything is to the power of 0, the answer is 1. If there's other stuff that's attached, then the answer is going to be a little different than just 1. Okay, so that's one of the easiest properties to know, as long as you memorize what the result's going to be. All right, now this next one is going to be tricky for some of us, and I've got a weird, quirky way of explaining it that hopefully will make some sense to most of you. Okay? And if you go and try to tell your high school teachers next year that this is how you did it, they're probably going to look at you like you're weird because they don't explain it this way. But it does work, and I've seen it work, so I'm going to keep going this way. All right, first I'm going to give you the algebraic definition, and you can see why I've kind of changed how it's worded once you see how weird it looks in the first place. All right, so here's the actual rule. It says that x to the negative n power, which basically means anything to a negative power, is the reciprocal. So we're dealing with reciprocals here, which means flipping stuff, of x to the positive n power. Okay, so what this means is that when you have x to the negative n power, it is the same thing as flipping it and making it 1 over x to the positive n power. Basically, that negative sign goes away and your x to the power of whatever number shifts to a different position. All right, now that's the algebraic language behind this. When I explain this and in a way to get you to understand it and do well with it, we talk about exponents being happy or not happy. If an exponent is negative, it is not happy. It cannot stay that way. It has to become happy. And in order to do that, we move it to a new spot. So here's what I mean by this. And I'm going to show you through examples, and I'll keep talking this way until it sinks in for you, and you'll see how well you pick it up. If you have 3 to the negative 4th power, that negative 4 power is not happy, right? So we've got to move this around. Right now, if I were to create a fraction out of this, this is 3 to the negative 4th power over 1, right? So the 3 is not happy up top, so he needs to move. So you still have your fraction bar, but in order to make him happy, he's got to go to the other location. He doesn't like being up top, he's going to go to the bottom. When he moves to the bottom, you make him happy by taking the negative sign away. So it becomes 3 to the positive 4th power. And then because that's on the bottom, you have to hold the top spot with a 1. Now you're not finished yet because you are not allowed to leave exponents in a fraction. You have to actually evaluate them. So we need to go one more step further. 3 to the 4th power actually turns into 81. So the final answer to this is 1 over 81. Okay, but it's all about making those negative exponents happy and moving them from one location to another in order to create that result. All right, so let's take a look at another one. If I have 4 to the negative y power, right? If you don't see it starting off as a fraction, you need to automatically assume and conclude that it is sitting over top of a 1. It won't be there, but you need to know it's there, right? So now the 4 is not happy up top, so that's why the negative exponent is there. So we're going to set up our fraction bar and we're going to move it so it is happy. We're going to put it to the bottom as 4 to the positive y power. Because we can't have air up top, we need a number up top, we put a 1 to hold its place. Right? We can't do anything else with this fraction because we don't know what y is, so this is our final result. Okay, so sometimes your results will be an actual number or fraction. Other times they will be fractions with letters still in them that you can't do anything about. Always simplify your answer as far as you can though. All right, so let's look at another one. Sometimes you will have fractions in parentheses as your base, and they will always be raised to a power. Right? And the best way to deal with this is to give that power outside to everybody inside, just like we talked about with multiplication. So with this type of problem, you're going to give the negative 1 to the 3 up top, and you're going to give it to the 5 at the bottom. You have to share it. So this transfers into 3 to the negative 1 over 5 to the negative 1. Neither one of those numbers are happy, so we're going to switch locations with both of them. When I do this, the 3 to the 1 power is going to go down to the bottom. You do not need to put the power of 1. If you do put it, it's not going to change anything because 3 to the first power is 3. And the 5 to the first power is going to come up top. So your final answer for this problem is 5/3. Okay. Let's take a look at a couple of others, and then we're going to mix all the properties that we've done in the past couple days together and get you to look at it that way, because that's really what this class is about. It's not doing one individual property by itself. It's a mixture of properties all in the same problem together. All right, so if you look at number 4, right, you need to separate it and think about what's going on. This is really saying 4 times 3 to the negative k power. Well, all of this is sitting over top of a 1. But if you look at it in terms of who's happy and who's not happy, the 3 has a negative exponent. He's not happy. He's got to move. The 4 is happy where it is, so it stays. So on the top of your fraction, leave the 4 alone. But the 3, move it to the bottom and make the k happy. There's nothing else you can do to this, so there's your final answer. Okay, so hopefully you're catching on to the happy, no happy trick and that it's working in your favor. All right, now to put it all together. This next section is going to tie in all 3 properties from the last set of notes with the 2 properties from here. All right, I am not going to give you one problem that has all 5 of them in it, although there could be some creative that do that. All right, but these problems will have mostly 2 or 3, I guess. I don't think anything has 4 of them in there. But they could have several of the properties involved that we've done over the past couple classes. All right, so I'm going to start you a little bit basic, and we're going to build on this. The quiz that you take with this chapter that's not too far away from now will have problems exactly like this. So it combines all the properties together. If I give you 4 to the negative 3 power times 4 to the positive 3 power, you can do the make one happy, leave the other one unhappy kind of thing, right? Or you can think about the multiplication properties. We had a property that said if the bases are the same, add the exponents together. Well, both of my powers have a base of 4, so I'm going to leave my base of 4, and I'm going to add negative 3 plus 3. Well, that gives me 0. And now that you've learned the properties from today, 4 to the 0 power is 1. So your final answer is going to come out being 1. Okay, so it really comes back to you knowing these properties and knowing them well enough to use them. But there is no one right way to go through the problem. There is one right answer, though. So now if I have 5 to the negative 2 power times 5 to the negative 3 power. Again, I see that both of my bases are 5s, so I'm not going to do any strange math with it. I'm going to take and use one of my properties from before. If my base is 5, I'm going to keep it a 5, and I'm going to add the exponents together. Negative 2 plus negative 3 makes negative 5. Right? Now, you're never allowed to have a negative exponent in your answer, so you know you're not finished. This problem is not happy. Put the 1 underneath it and move it to make it happy. So we're going to take the 5 to the 5th power and put it on the bottom. and then that means the 1 has to go on top. Remember, you can't leave exponents in your fractions, so we have to finish this one more step. 5 to the 5th power actually comes out being 3,125. So your final answer is 1 over 3,125. And yes, you have to write it that way. There will be no exception for decimal answers. They will not exist in this topic. All right, so looking at another one, if I have something as basic as 4y, all in parentheses, to the negative 3. If you remember from your multiplication properties, if there's a power outside, you have to distribute it or give it to all the things inside. Because I have 2 things inside these parentheses, the negative 3 has to go to the 4 and it has to go to the y. If there was only one thing, then we'd only give it to one thing. If there's 5 things inside, you got to get it to everybody. So this is really rewritten as 4 to the negative 3rd power times y to the negative 3rd power. And if you recognize it, neither one of them are happy. Right? And right now, both of them are sitting on top of 1. So we're going to flip them. All right? We're going to move them around to make them happy. The 4 is going to go to the bottom and become 4 to the 3rd power. The y is going to go to the bottom and become y to the 3rd power. And then your 1 will stay up top. You're not finished yet. You're never allowed to have a coefficient in front of letters that's a power. You got to evaluate it. So 4 to the 3rd power is really going to turn into 64. So your final answer for this one is 1 over 64 y to the 3rd power. And that would be a finished answer. Okay, let's take a look at some others. Okay. If I have 4n to the negative 2 power times, or in parentheses, and then negative 3 powers on the outside. Again, remember, whatever powers outside has to be given to everybody inside. So the 4 gets the negative 3, and the n to the negative 2 gets the negative 3. So this becomes 4 to the negative 3rd power times, and then you have a power of a power right here. When you have an exponent raised to another exponent, that means you multiply them. Negative 2 times negative 3 is going to create n to the 6th power. These are all of your multiplication property rules that we practiced in the previous class that you've got to stay on top of. Right now, if you look at it, the 4 is not happy, but the n is happy. So we're going to put them over top of a 1 because they're currently sitting there. We're going to leave the n alone because nobody's unhappy with him. He stays into the 6 up top. But 4 to the 3rd power is going to come to the bottom. And if you want to go ahead, because you know 4 to the 3rd power has got to be turned into a regular number, go ahead and write it that way. 4 to the 3rd power turns into 64. Okay, so you can do that in one move if you remember what to do with it. Otherwise, write it as 2 separate steps. Okay, the next 2 I want to do kind of simultaneously, only because they look very similar but have very different answers, right? And it's something that you're going to have to be careful with. And actually, I'm going to do 3 of them together because you're going to notice something very different and very similar about them at the same time. All right, if I have 0 to the 3rd power as the first one, and then if I have 0 to the 0 power, and then if I have 0 to the negative 5 power. Okay, you need to go back to your first property that we did today and look at the definition of the power of 0 rule. It says that a non-zero number to the 0 power is 1. All 3 of these numbers in the base spot are 0, so that rule does not apply. So for number 6, 0 to the 0 power is not 1, because that's not a non-zero number. That is 0. Right, now if you think about this, 0 to the 3rd power is really 0 times 0 times 0, so that's going to be the answer of 0. Okay, but if you think about number 6, 0 to no power at all, you can't do it. It's not 0 and it's not 1. Okay, so when 0 is raised to some other power other than a positive number, our answer is going to be undefined. And the calculator will say error because you can't do it. Okay, and then when you go to do the negative exponents and try to make them happy, okay, this guy's sitting over top of a 1, so when you go to flip it and put 0 to the 5th power in the denominator, 0 can never exist in the denominator of a fraction. That's not possible either. So again, that would be undefined. So the only time you get an actual answer when 0 is involved is if 0 is raised to a positive power. All other times your answer will be undefined, no matter what's in the problem. All right, then let's take a look at 2 more examples for your notes that kind of tie in several of the properties at once, and then the rest of the examples that you will be doing are going to be in class as practice and spread throughout this video in your educating questions. All right, so if I start with this one, 1 on top and 4x to the negative 10, y to the 14th on the bottom. and I'm looking to make the ones that are not happy happy because there's nothing else going on in this problem that I need to do. All right, the only thing that is not happy is the x, because that is the only thing that has a negative exponent right here. Okay, so that's the only thing that's going to move. Everything else stays put. Okay, so that x is going to come to the top. Well, I don't need the 1 anymore because now the x to the 10 is going to be up there. But on the bottom, the 4 stays because he's happy there, and the y to the 14 stays because he's happy there. So this would become your final answer. Notice there's no negative exponents and there's no evaluating that I need to do or simplifying. Okay, and then the last one that we'll take a look at through your notes is one that looks like this. I have negative 4x squared over top of 2x to the negative 1, and all of that is raised to the negative first power. When a problem looks like this, it has several properties involved in it. You always want to start with the distributing aspect first. In other words, give everybody in those parentheses, both top and bottom, a power of negative 1. Okay, so that means it goes to the negative 4, it goes to the x squared, it goes to the 2 on the bottom, and it goes to the x to the negative 1 on the bottom. It's got to go to everybody. Right? So after doing this, because negative 4 is in parentheses right now, it's got to stay in parentheses. Okay? You will totally mess up your answer if you take it out of parentheses. So this is negative 4 in parentheses to the negative first power. X squared, because it's power of a power, we're going to multiply. That becomes x to the negative 2. There's the new top. Go to the bottom, you're going to have 2 to the negative 1 power. And when I give x to the negative 1 a power of negative 1, that becomes x to the positive 1, because negative 1 times negative 1 is positive 1. Okay, now you're at the point where you can make things happy. Okay, and when we do that, we're going to move them around and shift them around until everybody's in a location that's going to work for us. Okay, so the negative 4 that's at the top is not happy there. He's going to go to the bottom, and you can still keep them in parentheses right now because he'll eventually go away. Okay, the x that's at the top is not happy. It's going down to the bottom. On the bottom, the 2 that's down at the bottom is not happy. He goes up top as just 2, because 2 to the first power is 2. And the x on the bottom is happy there, so he's going to stay on the bottom. Right, now, we've got to clean this up a little bit. You can't have more than one of each variable in here, and your numbers need to be simplified. Right? You always reduce any kind of fraction work you've got going on. Right? If I look at just my numbers first, the 2 and the negative 4 part, that is a fraction. Those are just regular numbers. We can reduce those. So in your final answer, it's going to be a 1 up top and a negative 2 on the bottom. It really doesn't matter where that negative sign goes. If you want to put it up top with the 1, you can. It's as long as it's there, it'll be okay. And then these x's across the bottom, we don't need to leave them separated. When we have all of them together on the same level, we need to combine them. Because they all have the base of x, we're going to add them together. You've got 2 x's in the front and you got 1 behind it. So that leaves you a grand total of 3 x's. So your final answer for this problem is 1 over negative 2 x to the third power. Okay, that's the point of simplifying and using all of these properties to get you there. Right, so you do have to make sure that you're staying on top of things and that you know when to multiply, when to add, and when to flip, and how to deal with these properties. We will continue to practice with these in several classes between now and then, but your quiz will be coming up in the next few days as well. Right, so any questions you may have, make sure you jot them down or think to ask about them in class.